And I have already explained how can we solve the linear algebra equations. And now we want to extend our view to other types of matrix equations. For instance, Lyapunov equations. And it has a mathematical form like this. So our question is, how can we find the numerical solutions or even analytical solutions to this kind of equation? And then we will talk about discrete Lyapunov equations and even more complicated, generalized or Bell-based equations. So let's consider this equation first. If A and C are known, how can we solve the equation to find the x? It seems to be quite complicated. If you do not have any experience in solving this kind of equations, it seems to be quite complicated. So what we need to do is to use existing Matlab function LYAP to solve it. And if you call this function, you can find the equation to the Lyapunov equation. And this function is provided in the control system toolbox of Matlab. So if you know A and C, you can solve it directly. So let's consider an example first. Suppose A and C are given matrices. How can we solve the problem? How can we solve the Lyapunov equation? And how can we verify the result? To solve the problem, what we need to do is to enter A and C first, and then call LYAP function. And then we can use norm function to check whether if we substitute this result back to the original equation, what is the error? And this kind of command can result in the following data. This part is the numerical solution to the existing Lyapunov equation, and this is the error. It seems to be quite small. And the question is, can we get a better solution? If you are not quite happy with it, can we get a better solution? Or can we have analytical solution to the problem? To find the analytical solution, we need this kind of manipulation. First, we need to rearrange the original X matrix and C matrix in this way. If we rearrange the matrix, we can get a row vector, or even a column vector, similar thing. We can have a row vector, first row, followed by the second row, followed by the third row, and then we can rearrange the matrix X in a row vector. And we can also express matrix C in the same way. We can express them in the vectors like this. And then the original Lyapunov equation can be transformed, can be rewritten in this form. Now we know C is a column vector, X is a column vector. For a 3 by 3 C matrix, we will have 9 elements C column vector and 9 elements X vector. And we use this product here, which is a special product called chromatic product. And the mathematical form of chromatic product is something like this. And the computation of chromatic products can be obtained by calling chrom function in Matlab. We have A and B, then we can find the C matrix directly. So just ignore this, and if we know how to use chrom function, that's enough. And in this way,
that's a matrix which every input is a matrix.
Sorry?
That's a matrix in which every input is a matrix. That
A matrix. Every element in A is multiplied by the whole B matrix.
okay.
And so we may have a very large matrix. If we all follow the 3 by 3, then the result could be 9 by 9. line chicks. And if you know how to perform A product and B, then the original problem can be transformed in this form. And you can recognize this is the matrix, this is the column vector, and this is the matrix. So there is an analytic solution. This is the A x equals B type of equation. So we can solve that easily. In this way, we can solve the original Lyapunov equation as an Ax equals to B type of equation. For this kind of problem, we can use Matlab command like this, and I will not explain too much about this. Since I have already written the Matlab function to solve this. So here I just want to show that the original problem can be solved analytically with the code here. So do not have to go into further detail about the code, and I also not want to explain too much about it. So this is the result, analytical result. So A times X plus X times A transpose plus C should be, sorry, A, lowercase x, sorry, should be 0. So we can find the analytical solution to the problem. I'm not going to give too much detail about the code itself. Later on, I will address a Matlab function to this purpose. And also, if C is a complex matrix or A is complex matrix, it also works. So we can use the same commands to solve the problem. And also, there is a discrete Lyapunov equation in control. And for this equation, if we use control system toolbox function, D Lyapunov, we can solve it directly.